Okay, so this is an overview of question 6, paper 2, 2015, which is a vectors question. Now, you're given lots and lots of information here. And the first thing that we probably want to do and think about is, can we summarize lots of information? Can we add it to the diagram? So before I do anything else, first thing I'm going to do is spot any parallel lines that I have. Now, this line here and this line here are parallel. So with that in mind, I've got an R here. So I'm just going to mark that as the vector R as well. We don't have a vector on it, but that line and that line are parallel. It's probably worth kind of just bearing that in mind, knowing that. Other things that we are told the length of P equals 3. So we're told that length there is 3. That's what the two straight lines with the P in between and the 3 mean. I'm told that ABC is a right angle. That's on the diagram. Brilliant. Last thing that I'm told ABE is an equilateral triangle. Mark that just by putting these two little dashes. Now, it's not to confuse things by having too much in our diagram, but it's good to just use all the information we've got, see what we can put down, because all of these different things are going to come in handy. Now, first part, we are asked to deal with P dot Q plus R. Now, as soon as I see a dot product with a bracket, I want to apply the rule that says, okay, you can expand a bracket even if it's a dot product. So that says that's the same as P dot Q plus P dot R. Now I'm looking at my diagram and thinking, where are P and Q? Where are P and R? And what can I do with them? Well, I immediately spot P is here and R is here. I know it's up here as well, but this P and this R are at right angles to each other. I have a handy fact that says any two vectors are perpendicular. If I dot them together and they are perpendicular, I get 0. So that's good. That's half our situation dealt with. Second thing I want to do, P and R, well, they're here and here. Well, I'm thinking, how are these related? They're not at right angles, but I do know, and this is in the formula sheets, you can look it up. There's a little formula in the formula sheet that says A dot B is the same as length of A, length of B, cos of the angle in between. I can't actually remember what letter it uses in the formula sheet, but this is the angle in between our vectors, which is in here. So the angle between our vectors comes into it. Oh, now I'm looking at my triangle and I'm thinking, what do I know? Well, this is equilateral. That means the three angles must be the same. So this angle between our vectors P and Q must be 60 degrees. Now I can use this formula. The last thing I'm going to need to know, I know the length of P, the length of Q, well, again, it's equilateral. So that length there is 3. Now we can use our formula. So P dot Q is length of P, length of Q. I might actually just write this down. Length of P, length of Q, cos alpha, which is the angle between the vectors. P and Q are, length of P is 3, length of Q is 3, cos 60 degrees plus 0. A little bit of work to do here. It's calculator paper, so you can use cos 60 in your calculator, or you can remember that cos of 60 is a half. So 3 times 3 is 9, divided by 2 is 9 over 2, plus 0 doesn't change anything. So that's our answer to part 1. I know that's quite a lengthy answer, but we've done a lot of work on our diagram to get there. For B, express EC in terms of P, Q, and R. Well, I'm going from E to C, and I've got to find a route between E and C, which goes along P's and R's. Well, I'm spotting that if I go from E down to A, well, I'm doing Q backwards, so that is minus Q. I go from A along to B. Well, that's doing a P forwards, and then B up to C. That's doing an R. And we're done. That's EC. It's nice to write our answer just a little bit more tidily with the EC with the arrow on top equals minus Q plus P plus R. That's kind of the proper way to write the answer to that question. Now, finally, we are given some more information about dotting vectors. I'm going to have to do it down here. So we're given the AE dot EC equals something. As soon as I see this, well, I know a little bit of information about both of these, but let's just get in our head what's actually going on here. We're dotting this vector here with that vector there. Now, that's the same as dotting Q Q dotted with the vector EC, but we just worked out what EC is. That was minus Q plus P plus R. Now you might spot why I've done this. I've actually been thinking all along, I'm thinking, okay, this is a bit crazy. This is really confusing. Does it relate back? Well, okay, EC appears here, so maybe that relates to that part of the question. And by identifying that we're working with Q here, I'm thinking, oh, actually, I might be able to see a link back to this part of the question here. So it's all the way through, and we're kind of trying to link back to things that I've done when I've got one of these longer questions. Let's proceed. Well, this is not dissimilar to what we're doing up here. So we've got minus Q dot Q plus Q dot P plus Q dot R. And we're going to process each of these bits just like we did in part A. So let's do that. Q dot Q, now this is something we just need to kind of recap here. Let's recap this. So if we have Q dot Q, that is length of Q cos 0, because there's 0 angle between Q and itself. Q dot P is length of Q, length of P, cos the angle in between them. Now we've actually already done Q dot P. We did it as P dot Q. Exactly the same thing. So it's still 60 degrees in between them. And finally, Q dot R is length of Q, length of R, cos the angle in between them. Now, I'm not going to fill that straight in. We've got a little bit of thinking to do there. QQ, well, that is the same as length of Q squared, or 3 squared, so that is minus 9, plus length of Q, length of P, cos 60. We already worked all of that lot out. It gave us 9 over 2. And finally, well, we are now working with this last bit here. This last bit here is length of Q. Well, we know the length of Q is 3. We don't know the length of R, but that's what we're trying to find. So you'll spot I'm not really thinking about what I'm trying to find all along. I'm writing down what I can and then working with that information that I've got. Now, what is the angle between this line and R? Well, if I extend it out, if this is 60, and this is a right angle triangle, then this angle up here must be 30 degrees. So I get 30 in there. Now, we are told that all of this thing, AE dot EC, is equal to that. So I actually can replace this with 9 root 3, take away 9 over 2. And now we want to compare our two sides. We want to figure out what's going on with our two sides. So solve this a bit like an equation. So we've got 9 root 3, take away 9 over 2 equals minus 9 plus 9 over 2 plus 3. Now we need to work out what this thing is, cos 30. Use your calculator or use your brain. We'll tell you that that is root 3 over 2. And finally, we've got a bit of rearranging to do here. The rearranging that we've got is to move everything across that's not this length of r. So we're going to add 9 to both sides. So it's 9 root 3 minus 9 over 2 plus 9. Take away that 9 over 2 equals 3 root 3 over 2 times r. Faff around with this. 9 root, take away 9 root 2, 9 over 2, sorry, take away another 9 over 2 is take away 9. So actually find that, that, and that cancel out with each other. Again, if you want to do that in your calculator, this is a calculator paper. We're going to times both sides by 2. So that's going to give us 18 root 3, and we're going to divide both sides by 3 root 3. And that is our length of r. Now, it would be nice to tidy that up. Root 3's cancel out. 3 cancels with 18 to leave us with 6. And we're done. There is a lot of faffing about going on in the middle there. There are some steps which I've really kind of over-explained, because in some ways you could go straight from that bit to there because you've done it already. Knowing that the length of q times the length of q, or sorry, q dot q is just the length of q squared, is something that you might want to just kind of memorize. And this step here, you could maybe simplify in less steps, but hopefully you can see all the key ideas. I've really gone through that in detail so that you can see all the key ideas. 2 things to say before we finish up. First one, this is the only thing that you know how to do with dot products. The only other 2 little things that I've used is a dot b equals 0 if perpendicular, and I've used a dot a. If we dot something with itself like we did down here with q, that is just the length of a squared. So if you get a question involving dot products, like we had here or we had here, these 3 things are the only tools you have to go on. So that is basically, you're trying to use one of these 3 every time. In this first part, if you had not spotted that p dot r equals 0 straight away and you plugged everything into this formula, nothing goes wrong. So actually, even if you don't remember these 2 facts, you could plow on. All you would do is plug in length of p, length of r, cos 90. Cos 90 would give you 0. So don't panic if you didn't spot that this was perpendicular straight away. Even if you just use the top formula there, it will still churn out 0 for you. So that's hopefully a helpful overview of how I do that question. Quite a bit of work, particularly in part C. But even if you can get part A and B right, that's quite a big chunk of the marks for that question.